bit of background for me. I'm an architect. I qualified more than 40 years ago. I've been involved in MMC in various in offsite manufacturing in various types of buildings over the years. I think one of the earliest was around about 1988, when it was actually working Faslane submarine base, and we did a modular police station, which was actually quite tricky, quite a bit of a challenge. I worked on for the prison service in Scotland, where the buildings were prefabricated. This is concrete house blocks, obviously concrete structure. It's fairly robust and ideal in a prison situation. And I did some work for the RAF, the Royal Air Force, back in the early 90s, when they were beginning to look at ensuite bedroom and bathroom accommodation for the service personnel. And that eventually turned into a framework in 1992 for the modernisation of all the military services. For 4 years, I actually was head of offsite and offsite research for a major tier 1 contractor who is no longer in business. They went bust in 2018, but I've carried on and my involvement in offsite. So that's me. What I'm going to cover today, 4 out of the 5. I'm going to look at offsite definitions. The offsite definitions were actually written for the residential sector. However, the definitions apply across the construction sector and the infrastructure sectors. I'm also going to pick up on the construction industrialization process, of which there are 5 steps. And obviously I'll go into that in a bit of detail. Offsite in practice, some case studies. Again, I would mention that the webinars and the workshops were actually set up with architects in mind, architects and engineers. So we're beginning to pick up on case studies for infrastructure and civil engineering projects, but again, they're fairly limited at the moment. And if you have any suggestions, please drop us an email and we can actually look at expanding our portfolio of case studies. Implementing offsite looks at, again, as to how it was actually done for a major project in terms of identifying what could actually be manufactured offsite. And I've had a go at creating a matrix for highways. I'm not an engineer, but I've had a wee think about it and actually put something together. And again, comments on that would be most welcome. And then, as I've said, we have other workshops coming up later in the year. We've set up a Jamboard page, and you're quite welcome. Once the link's actually in the chat box, if you want to open the Jamboard page in a separate window without closing the webinar, and pop notes in any time you wish, although I have allowed some time at the end for that. So that's the content. This is our running order. Pretty much as I've actually described it on the content page. So to begin with, offsite definitions. What I've done is I've based this on the Modern Methods of Construction definition framework. The framework is the output from a joint industry working group. Construction Leadership Council were involved. The objective was to improve stakeholder knowledge and understanding of modern methods construction, which obviously is underlying, the underlying thing here is offsite manufacture, but there are other processes involved. It was partly down to educating the lenders and the financiers so that they fully understand what's proposed, because there was at a time probably, and there may still well be, this concept or this view that modern methods of construction are about prefabs, the prefabs that were built to address the housing shortage just after World War II, some of which are actually still standing, although they were only intended to have a limited lifespan. but the things have moved on in terms of OSM, offsite manufacturing, quite significantly. So the definition framework was set up. We've got 7 categories, which I'll describe in a bit more detail. The other thing which is in the framework is something called PMV, and PMV is pre-manufactured value. So if you're actually working on a scheme, whether it be any scheme whatsoever, any infrastructure project or building project, you can actually calculate pre-manufactured value. There are actually 2 ways of doing that. One of them is to add up the actual cost of anything that actually is delivered to site, which is pre-assembled or manufactured in some manner. So you wouldn't actually then say measure sand or cement or gravel if they are being delivered to site, but if you're actually getting precast components which are then assembled, they have a pre-manufactured value. The other way of doing it is to actually compare site labour. So if you have a site, one project where there's a large amount of precasting being used, the actual site labour will be significantly less in comparison with a project where there's a lot of in situ concrete being cast on site. So PMV is the principle of identifying the difference between sites in terms of offsite manufacturing. And obviously the higher the PMV, the more actual offsite manufacturing activity. So that's PMV. In terms of the categories, and it's highly unlikely that this category will be used on highways projects. However, that may not be entirely true. There may well be instances where some form of 3D primary structure is required. I think it's highly unlikely because this is really intended as residential accommodation or offices where the chassis could be steel or it could be a concrete box, preformed and fitted out. Although you could perhaps have a 3D culvert, precast concrete culvert or something of that nature if it's a highways project. So probably limited in its use on a highways project, but not perhaps completely unknown. The next category is 2D primary structure, which tends to be described as Flatpack. Possibly more potential in terms of retaining walls and other structures. As I said before, a lot of these images were basically set up from from an architectural and a building point of view. And this little diagram obviously showing you how a Flatpack works. One of the big advantages from a building point of view is that you don't need scaffolding to erect this system, as you can see from the image down the bottom right. There are various different materials used, quite commonly engineered timber, which is variously called glue lam or cross laminated timber. You also then get nail laminated timber. Again, potentially materials such as timber would have some potential use in bridge structures, depending on the environment. Obviously, if it's a motorway, it's probably not the right environment. But then again, cross-laminated timber actually is quite resilient in terms of its resistance to the atmosphere. It would actually colour in the same way as timber cladding colours. So category 2, 2D primary structure, variously called Flatpack. The next category is actually non-systemized primary structure. Now, the difference between systemized and non-systemized is actually the non-systemized tends to be individual elements. Now, I could actually envisage the elements in the bottom left here being used on a highways project. The illustration is actually from the FB McCann factory in Cheshire, and these the molds are for casting architectural features. That's the way they're described. So circular columns with obviously with bases and capitals. But I can imagine that particular approach being used for say over bridges or under bridges on a highways project. Not so much the one on the right, which is actually a prefabricated loft extension being lifted into place. But certainly there may well be a place for category 3. And I would imagine that there will be instances already where, say, bridge beams, which you would class as a non-systemized primary structure category 3, being used on a regular basis, obviously on highways projects. I'm trying where I can is to relate what I've got to highways and infrastructure. As I said, we're still in the process of developing this and actually linking it across and actually tailoring it and making it more relevant in terms of infrastructure and highways. Category 4, it's described as additive manufacturing, is effectively printing, 3D printing. It's developing quite significantly. The designers in the Middle East, China, Italy have all printed 3D houses, but again, there may well be cases where you could 3D print a retaining wall or other elements. The downside is having getting the robot set up to actually do the printing, and I think timescale wise, it's not the fastest of operation. Although in just thinking again as to how you might do that, motorway barrier, which is currently slip cast, could potentially be 3D printed. It would simply mean getting the robot set up such that it would run back and forward in lengths. Not entirely sure of just how you would actually incorporate rebar and make it work. But there may well be elements of highways where 3D printing actually could be of some sort of benefit. So category 5 is non-structural assemblies, sub-assemblies, covers a vast range of things. It's almost like a catch-all. Obviously, left-hand image here is tunnel linings from Crossrail. So I could foresee that being used, say, in pedestrian underpasses and things like that, where there's a obviously requirement for a good quality, robust finish, which can't be defaced. You might be able to spray on it, but at least it's robust. And then again, is the detailing around some of the structures. The prefabricated lintel assembly is from IG, and it's designed such that it clips onto a concrete structure or a background structure. Interestingly, when I've actually seen those being used, the bricklayers were actually turning them upside down and pointing them while they were actually on a bench, which then eliminates the need for them to lie on their backs on scaffolding and trying to point upside down. So there's obviously a health and safety issue. Big advantage in actually eliminating potential risk and potential workplace injuries. The category 5 also covers building services, bathroom pods, service risers, horizontal services runs, modular plant rooms, feeder pillars, electrical assemblies. It's sort of almost like, as I say, a catch-all category to pick up on anything that's not in categories 1, 2, and 3. I would have been inclined to make this category 4 as opposed to the additive engineering, but as it's turned out, this is the fairly wide. Non-structural assemblies, again, could be things like handrails for over bridges, where you actually could put together long lengths rather than using individual components assembled on site. I would imagine there are numerous opportunities to apply this particular category in terms of the highways and infrastructure projects. In category 6, I think the key words here are site labour reduction and productivity improvements. Bungalows are being built in Denmark using story height blocks, which is what you see on the right hand side. Obviously, there's a component retaining wall component which actually locks together as a precast block. And I could foresee that being perhaps used even as a temporary retaining wall. In this instance, the image I've got, it looks as if it's actually in a yard, which is being perhaps a concrete batching yard. What I'm left, something that wouldn't be particularly appropriate, but the principle here is quite interesting. It's described as dry screed board, and what it does is actually reduces the water content of screed in buildings, which is and it's much lighter than a conventional screed. But again, probably not something you would actually use on highways. And then finally, in the framework category 7, it's process led. And obviously, the drones are being used much more. I've seen illustration examples and demonstrations of drones, and some of the certainly listening to what's described in terms of the capability, perhaps looking at LiDAR. I mean, this category also includes things like weather encapsulation, where obviously if you're working on a structure in a particularly bad weather, you potentially could enclose the whole thing in some form of scaffolding and fabric cover. Category 7 also includes things like lean construction, wearables, which could be exoskeletons as they become more sophisticated and probably lower cost. Then you've got HoloLens, which allows you to actually see a 3D model as you walk through a building. So using a digital twin and some of the technologies available as you go to actually look at a structure. Potentially, I suppose on highways, you might be able to see where the rebar is in a precast element or even an in situ element if the rebar has actually been designed in Revit or the civil engineering equivalent. So these are the 7 categories in terms of the definitions. I think you will agree that quite a few of them actually apply across all infrastructure projects. In fact, any type of construction project. And what we end up with is an MMC spectrum with the 7 categories. So obviously covering offsite, nearsight is quite common, and I suspect that it's something that will occur in the infrastructure sector, is that nearsight will be quite common. I'm just thinking a structure like the Milo viaduct in France, where the bridge decks were actually manufactured near site. Well, that's part 1. So hopefully that's quite useful in terms of just understanding all the different terms. This next section is about construction industrialization. And construction and industrialization is the overarching process which includes offsite manufacture, but actually then looks at the other 4 constituent parts of that basically construction industrialization mindset. So the definition of construction industrialization is as you see on the screen. The 2 key words here are the very last ones, where possible. Offsite manufacturing techniques are not entirely suitable for every single project. However, with a bit of inventiveness, there's no reason why they shouldn't be applied to some elements of it. So the actual mindset looks like this. It's led by, obviously, the design stage. Without the design, without thinking about offsite manufacturing at the very start of a project, you're going to limit what can actually be done in terms of offsite manufacturing. So DFMA, if anybody's interested, we actually run a separate seminar. Latterly, the supply chain school collaborated with the Royal Institute of British Architects to produce an offsite overlay to the Royal Institute of British Architects plan of work. And the school actually does have a workshop based around that, looking at the different stages. We also have workshops and webinars looking at logistics and on-site assembly, but even in the enablers here, change management, project management, collaboration, all of these topics are covered in some way or other. So starting with DFMA, as I say, it's based on the RIBA plan of work. Missing out the British here. The little diagram at the top is actually a comparison of architectural design resources on an OSM project, offsite manufacture project, compared to a traditional project. And the same could apply in terms of any of the design disciplines resources. The front end is pretty much the same as you would expect traditional compared with OSM. So grey here is the darker one is part of the graph is actually the OSM. And specifications and designs tend to be fixed much earlier to allow the offsite manufacturing to go ahead. There's less opportunity to change. So once you've imposed a design freeze, there isn't a great deal for the designers to do, and that would apply across all disciplines, regardless of the project type. You can see how in a traditional project, there's a huge amount of site queries, site clarifications, and potentially also site inspections. The one thing about OSM is if you're actually manufacturing in a factory or factory conditions, you can then do your inspections, you can do your quality control checks off-site before things are actually then delivered to site. And that has a major impact in terms of resource requirements. So from a designer's perspective, you potentially can move on to the next project far quicker if you have a limited amount of resource. With the resource tailing off far more quickly on an OSM project, you can then move on to the next project more quickly. And the same would apply from a construction perspective. I think the estimate is that you can do two OSM projects or 3 OSM projects in the time it would actually take to do 2 traditional projects. So significant increase in productivity. So, as I say, DFMA is the enabler. It's if we're not designing for manufacturing assembly, then you really are limiting the opportunities to look at offsite manufacture. So I'll stress again, we're looking at process. We're not looking at particular civil engineering or highways engineering. In focus, we're actually looking at the overarching methodology and process which could apply to any type of project. Interestingly enough, it's nothing new. The little diagram at the bottom left here is actually an illustration of how the Stonehenge sarsen stones were actually carved and the lintels were carved. So if you think back to the image I showed in terms of the category 6 with the large precast blocks with the dimples, it's not particularly new. It's been around for a long time. And interestingly, the mortise and tenon horizontal joint harks back to or is a reminder of timber engineering. I've got another example of that from an infrastructure project later on, where where timber technology was the basis for the design. So DFMA, the start of this construction industrialization process. Next stage, obviously, is offsite manufacture. No apologies again, looking at architecture. The project on the right is the tallest residential, modular volumetric residential project in the world. It's in George Street, Croydon, 43 stories. The issue there is actually production time and stockpiling capacity, and finding a manufacturer with the capability to actually obviously to build all of the modules, because I think it was something like 27 modules per floor. Obviously through 43 floors, that's quite a lot. When it comes to OSM, the lead-in periods are different. I've mentioned design freeze previously. Again, a lot of OSM is driven by a very early design freeze. It could well be a prescriptive specification rather than being a descriptive and finite specification when it comes to OSM, such that the manufacturers and suppliers can have some sort of input and provide their knowledge and expertise as part of a collaborative process. So we go moving on to logistics. Obviously, I think I would imagine highways engineers will be pretty much familiar with the various issues relating to logistics when it comes to the UK road system. It's just letting architects know that motorway bridge standard is 4.8 meters. And obviously, certain parts of the country have major limitations when it comes to moving large and abnormal loads. I'm thinking inside the M25, for example, and then in the City of London itself, I think it's between 1 AM and 5 AM for any major loads, large loads going in. I mean, what we're looking at here in terms of logistics, bottom right, that's the images courtesy of Scottish Transport, or sorry, Transport for Scotland. It's actually one of the bridge deck units for the Queen's Ferry crossing, which was opened a couple of years ago. The bridge deck units for that project were prefabricated in Shanghai. The company who actually manufactured them is better known for manufacturing dockside cranes for container ports. Apparently the manufacturing process took up something like 75% of their yard space. Would imagine from a UK perspective that it would have been difficult to find a manufacturing facility with that capability. But it's an offsite manufacturer on an international scale. I think it was 110 units. It's something like 750 tons each, transported halfway around and then obviously unloaded at Rosyth on the north bank, close to the bridge. The bridge decks, the concrete bridge decks, and the mechanical services were actually then added. With the size and weight of the units, the mechanical handling systems, the cranes were specially designed to actually lift the bridge decks from barges on the river and lift them up onto the deck. So logistics has to be taken into account when you're looking at offsite manufacture, obviously because of the constraints of the road system and potentially the limitations of actually having the right equipment to lift them and lift the assemblies and whatever's been pre-manufactured into place. The on-site assembly is similar problems, not similar problems, similar issues in terms of lifting, etc. Again, here we've got bottom right. I would not like to be the gentleman who's actually standing on the outside of that jetty. It's a rather large bathroom pod which is being maneuvered into place. It's a snapshot from a video. It was successfully done and no one was injured actually in the process. But it's again, large assemblies manufactured off-site have their own issues to deal with when it comes to lifting them and securing them in place. You know, one of the techniques for off-site manufacturing assembly is actually foolproof assembly. And if you actually think about it, the 13 amp, 13 amp plug, we'll say 13 amp. UK plug is designed to go in a socket, and there are, in theory, you should never be able to put that plug into the socket, power socket, the wrong way. The Japanese have a term for that, which is called poka-yoka, which is about foolproof assembly. And it's a technique you can use, or it can be used for off-site manufacture, where obviously the different assemblies are designed such that they plug together. They can only go together in one particular way. I mentioned it before with offsite manufacturing. You have the opportunity to do testing and commissioning offsite. You can do your quality checks offsite. You're looking for that simplicity of assembly. You could, if it's a repeated element, if you're having something manufactured which is going to be used multiple times, you can then have a prototype made, set the standard for that, and have that as your quality check. Almost like you're almost doing your snagging in the factory before anything actually arrives on site. Possibly an awful lot safer, an awful lot simpler. So that's the assembly stage. You're going into the maintenance operation. We're getting into the category 7 in terms of the MMC, with a lot of the technology inputs. I think the key thing here is again, as designers, if you're designing something which has got a significant maintenance requirement, is to actually think about how that facility will be maintained, where that structure will be maintained at the very start of the process. So again, the emphasis here is to encourage the designers to be thinking about planned maintenance and obviously maintenance access. With OSM, from a building perspective, the tolerances are far tighter than they are for, say, site construction. Although they have improved over the years, but they go back a few years where concrete structures were probably plus or minus 25 mil, whereas the tolerances are far better now. But certainly when you're actually manufacturing something, you're working to tighter tolerances, and the tighter tolerances actually result in a more energy efficient structure. Although again, in highways, I would imagine that's not a particular issue, as you're not enclosing spaces, or very rarely enclosing spaces, and you're not having to. You don't have plant and equipment that's running that it's actually using up obviously resources. So these are all things to think about in terms of OSM. Some of what's listed on this particular slide perhaps isn't entirely relevant when it comes to highways, although I would have thought user and worker safety and comfort are quite important. And obviously we're looking at a digital twin nowadays, and it's making that digital twin usable and understandable for, say, clients and operation and maintenance staff. So that's these are the stages of construction industrialization. I think underpinning all of this actually are these items. I often think that when you look at collaboration, and certain organizations I think are far more enlightened when it comes to collaboration and frameworks than others, and I think national highways probably are in that category. But if you think about the construction industry and possibly the infrastructure industry, you potentially have a client at the center of an atom, a nucleus, with numerous consultants initially spinning around trying to win some of the work that they actually have available. And if you take that to the next step, you've potentially got a tier 1 contractor with numerous suppliers, SMEs and others trying to get involved in a particular project. And at the end of the day, what it comes down to is teamwork and collaboration. Obviously, teamwork at top right and bottom left. And the last time I looked at that image on the bottom left, I counted 23 different helmets, including the one in the car itself. So teamwork obviously has its place to play everywhere. I think what we need to see to encourage collaboration is a different approach in terms of business models, and obviously different behaviours. In the past, as the construction industry was very adversarial, I think a lot of that's going, but it still exists in some cases. It's not gone completely. So it's not just the actual stages of the construction industrialization process that need to be considered. It's these other factors which can have a significant impact on any project. And then looking at behaviors, and I can see that typically my system has decided it's going to change the font sizes automatically without referring to me. But we have a sort of mindset wheel where we're actually looking at cues and obviously a way of actually approaching this. So you're working on a project at some point. What we're saying is we need to make construction industrialization and DFMA easy, and it comes down to understanding the process, the terms, etc. And so we make it easy, we make it understood. Obviously, if more people are actually implementing offsite and MMC and DFMA approach on projects, it becomes more of a norm. If there are clear benefits, it makes it desirable. If you combine the cues, then it becomes rewarding. And then if you combine the cues and make it rewarding, it becomes a habit. So it's about process and methodology. Okay, offsite in practice. A few case studies with descriptions of the benefits and various other elements that are going on. Starting with a building, I'll make no apologies again. This is a kit of parts. It's a Langeroog project in London. You can see how various elements came together. It's debatable if I go back to the category descriptions as to whether this is a category 3. Obviously non-systemized, or whether it's actually a category 2. But I think the difference in definitions is actually about a system is designed to work together, whereas if you're actually, say, designing columns and walls and beams, etc., and they're not part, it's difficult to decide whether they're actually part of a system or not. And in this case, 70% of the building was actually manufactured off-site. The way to think about a kit of parts is what Bride and Wood are actually doing. For those who are into modelling, what this illustration reminds me of is actually an airfield kit. Airfix kit, sorry, not airfield kit, airfix kit. If you're interested in just understanding more about this particular approach, there's an explanation, there's a Vimeo video explaining the sort of principles behind this. And I've taken a snapshot from that video, which actually looks like this. So you take the core at the bottom by working out what buildings have in common. If you take out buildings and just simply put in projects have in common, infrastructure projects, highways projects, So the principle, again, its principle here is thinking about what can be repeated and what elements could be manufactured as a kit. This is described as platform design, where obviously elements are the use of elements which are designed once is maximized. So principle, having a think about it, and just going back to the previous illustration. These are the actual gains, the benefits. The Langeroork approach is 70-60-30. You can see top left where we've actually got a culvert or a service duct, major service duct of some kind, which I could foresee being used. Infrastructure projects, but the principle here is 70-60-30. 70% manufactured offsite, 60% reduction in site labour, and a 30% reduction in duration. And you can obviously then see where they've actually looked at structure, the cycle to construct one floor compared with in situ. So DFMA offsite manufactured solution 6 days against 9 days, and then you can see the variance in terms of the 60. In fact, it's a 60% labour reduction and the 33% time reduction. What's not shown there is the 70% offsite manufacture. Anyway, an example of precasting. This is the 2.5 meter long, 1.4 ton linear drainage, obviously, for the, as you can see, for the M6. Offsite manufacture in this case resulted in better quality with tighter tolerances. There's something like 14 kilometers of this in the central reservation, 17 kilometers in the verges. So opportunity for massive amounts of repetition. As you can see, there's a bit of poka-yoke here with spigots, such that the units can only then be assembled, the male connection, female connection, so that they can only be assembled in one way. Productivity rate was something on the order of 200 meters per day. So one small element might seem to be fairly insignificant in terms of the overall project, but it does make quite a bit of difference. It probably takes out quite a bit of interface issues as well, and waiting for concrete to cure. And unlike obviously slip casting, this type of assembly, it eliminates any weather issues. This is taken from a reservoir, which is a post-tensioned walls. Now, again, I could foresee this as being sort of used as a retaining wall structure, or in this case, it's obviously designed to hold water. There was early engagement with the supplier, obviously Shea Murta, the precaster, and they developed, although it's a simple structure, they developed a 3D model. It was all manufactured off-site, and it significantly reduced the actual site time and the amount of labour required on site. Now, it was a fairly remote site, so that had the benefit of actually cutting down the amount of time that the workforce, the labour force, were actually having to spend away from home. Quality inspections were all done off-site prior to delivery. So again, nice dry environment to do the shall we say, the snagging, the quality assurance assessments. And it also, in this case, eliminated working at height. You can see it's probably 2 and a bit times the height of your average man. And by using the precast approach, offsite manufacturing approach, it eliminated a number of issues. It's debatable again as to whether you describe this as a kit or a system. it's verging on a system because it's I think the joints the joints are being designed such that there's an interlock, there's an interface between the components. But I'm not sure. This is where the framework definitions are slightly at odds. Moving on, slightly different approach. This is actually London Bridge Station. And what was done here is very, very busy station. I think it's the third busiest in the UK, and limited access. Contractor only had access to the platforms. I think it's 2 or 3 platforms at a time, and for limited time period, given the obviously the need to keep the rail services running. So in this case, Severfield and Shepherd Engineering Services and the cladding contractor got together, and they actually built a 54-metre long prototype off-site. So they basically assembled things so that the CCTV cameras, the lights, all the services were actually incorporated into the as were pre-manufactured into sub-assemblies. So they assembled the prototype. They then dismantled the prototype, but they didn't actually take it to site. What they actually did is they assembled it again, because they came up with a few glitches when they assembled it the first time. So the second run eliminated all the glitches. So Prater was the actual cladding contractor on this. By actually pre-assembling that prototype and removing any issues that came up during the first phase assembly of the prototype, when they went on site, the canopy assembly went fairly straightforwardly, and they were obviously able to complete the project on program. If you haven't been into London Bridge Station since it's been modernised, it's well worth actually a visit downstairs, where the old Victorian railway arches were actually removed to create a new concourse. And there's an interesting technique for the platform. Some of the platforms had to be raised. Originally, I can't remember how many the split was, but some of the lines actually went all the way through and into central London, whereas others actually stopped, and the stopping platforms had to be raised so that the number of through platforms could actually be increased. And to minimise the load, polystyrene void formers were used under the platforms to reduce the mass of concrete. And it maybe it's possibly a technique that could be used in infrastructure projects where there are concerns about bearing capacity, structural loading capacity. An interesting project all round. Illustration from Crossrail in terms of how OSM can significantly improve productivity. So another Laing O'Rourke project. You can actually see from the metrics in the top right here what the difference was in terms of man hours for a precast solution compared with an in situ solution. The issue being, of course, again, that the precast solution does tend to need mechanical handling assessment, potentially specialist equipment, but significant potential to improve productivity and speed things up. This next one touches back onto what I was mentioned earlier. It's the 110 bridge deck units, each weighing 750 tons. Illustrations courtesy of Transport for Scotland again. Global offsite manufacture. Quite impressive. Would be nice to get an up-to-date image of the finished facility. For those of you who aren't familiar, the bridge in the background is the fourth bridge. It doesn't use the word rail. It was the first one there. It's the fourth bridge. The middle one is actually the fourth road bridge. And of course, we had to come up with a different name for the last one, which is the Queen's Ferry Crossing. Interesting project. This is a little illustration of something that has been done in London, Crystal Palace. The bridge is actually made from one piece of steel, or almost one piece of steel. Or certainly the deck and the beam underneath and the rail actually is one sheet of steel. And you can perhaps see in the bottom left how it was actually done. It was actually cut into fingers. And the fingers were actually, some of the fingers were bent downwards to form the structural beam. And some of them were actually bent upwards to form the balustrade, the handrail. So just a little bit of innovative thinking here, and possibly a technique that could be used on infrastructures for bridges if there are, say, pedestrian footbridges required. The only limitation in this case is the maximum length of that can be galvanized in the UK. But an interesting technique. The actual approach of cutting the steel into fingers reduced the actual welding required. So what you would normally have to do for a design like this would be to obviously cut everything into fingers and then weld it all together. So quite a significant reduction in the actual welding. The base plate for this is 10 mil thick steel. So quite an interesting little project, and just quite an innovative technique, which looks very attractive for a very simple approach. And I mentioned earlier that timber technology has been used, and this to me is an illustration of how offsite manufacture is nothing new. It's been going on for a long time. In fact, the Chinese developed a timber frame system, which they used to build the Forbidden City 500 years ago. In this case, what we have is obviously the earliest cast iron bridge of a significant size. Apparently there were two others, one in France, which was started, although it wasn't finished, and another one in Yorkshire over a pond. But this is recognized as being the first in the world. It was designed by an architect, and if you have a closer look at some of the components, they're actually mortise and tenon joints. It's actually based on timber technology. So I think the message here is that with a bit of imagination, obviously, you can actually offsite manufacture. The difficulty in assembling Iron Bridge was actually the main ribs themselves, and getting them obviously up and logistics. I think it's relatively close to Abraham Darby's foundry, simply because the transport infrastructure wasn't in place at the time. But I think looking at technology, so this was on the cusp of moving from timber structures and timber technology, in some cases, to cast iron metal technology, and we're at a stage now where there are different technologies available. So again, it's looking at what's available and what can be done from an offsite manufacturing perspective. And then finally, as I've just said, things keep changing. So what we've got top right is a stainless steel printed bridge in Amsterdam. We got somebody, Brian, if you could have a look at the chat box. There's something in the chat box. I'll pick up on the chat box later, folks. Bottom right is a 3D printed building. It's the largest 3D printed building in the world at the moment, 9.5 meters high, 640 square meters. It's an admin building in the Middle East. And then on the right, what we're looking at is a post-tensioned stone assembly for the Sagrada Familia in Barcelona. The site team, the construction team, have collaborated with Arabs to develop an assembly. And again, okay, it's a cathedral, it's a building, but the principle again is looking, if you're having to say stone face something for in a particularly special environment, then there's no reason why you can't perhaps look at pre-assembled components to actually fix onto a primary structure. The stainless steel bridge is now in place. It was actually lifted into position. I think it was last June or July. I do actually have some images of it actually being officially opened, but it sat. I think it sat in the production yard for about 18 months because of the pandemic. So lots of scope, new technology, different ways of thinking. Don't close your minds to OSM. There might be just something that's of interest that you can come up with. Just going to have a quick look in the chat box, folks. So, just a comment from someone at the Advanced Manufacturing Research Centre in Sheffield. Yeah, quite impressive. I don't know if anybody's ever been in there, but it's quite an interesting technique for training students and apprentices there. Anyway, I digress. I shall carry on. Implementing offsite methodology. How might you actually go about it? So we've spoken about the categories, the definitions. We've looked at construction and industrialization. We've looked at a few case studies of offsite in practice. Hopefully I've been able to link this to highways and to infrastructure, because as I've said, it's about buildings. And unfortunately, that theme will carry on in terms of buildings. You're building a residential tower block or a residential building. Is how on earth do you actually decide what's the best method to use, what's available, what are the actual drivers behind the whole thing? I wouldn't expect anybody to read the bulk of this. But this was an analysis that I did in terms of actually looking at potential construction methods. As you can see, it's a bit out of date. The volumetric hot rolled steel is now up to 43 stories. The light gauge volumetric in column 2 there is 40. I think that's been challenged. Concrete's 40, but going to go higher because Singapore are actually challenging the world record for the Singapore, interestingly, use concrete boxes for the modular residential accommodation. So again, its principle is I'm sitting down, I'm looking at a project of some kind. I've got all these different options. So I do some analysis and try and actually identify what's best. And just going through all these various criteria, I can identify what might well be the best thing for a particular project I'm looking at. And you could apply the same principle to virtually any project. This was actually the approach used for a hospital project. It was a PFI. So what we did here is we looked at, obviously down the left is the elements and components, and then just picked some assessment criteria, keeping it relatively straightforward. And the approach is yes, no. So foundations time consuming, yes, no. 1 is yes, 0 is no. And apply that across the entire matrix. So if you stick to that binary approach, you could actually grade them. You could actually say, well, foundations are time consuming, but they're not that time consuming. So if we go on a scale of 1 to 10, it might be a 6. However, in this instance, my approach was to use binary. So let's keep it simple. Yes, no. It's a high level assessment. You're not trying to go into any detail at this stage. The idea is to try and identify where the opportunities are and where best to put your resources. So when this was scored, it actually looked like this. The team decided that they wanted a maybe, which is why the 0.5 crept in. But what this then did is with a high, we decided the high scores, obviously above 4, that's where we would actually start to look at putting our time and resources into the offsite element of it. So again, you could apply this to any particular project by just deciding which elements, components that you actually want to assess. The team that scored this included the designers, the construction managers, and some of the actual clinical specialists from the PFI team. So it wasn't just about designers and deciding or construction team deciding. It was a collaborative effort to try and identify where best to put time and effort into investigating different elements. And interestingly, in this case, BIM came out fairly high on the list, although, and as a result, a training facility was actually set up in the local area to help inform the actual background process and the supply chain, and contractors who were interested in tendering for some of the work were actually invited to come along to some of the BIM workshops so that they would understand exactly what the long-term objectives were in terms of federated models and data-rich objects for inclusion in a very high-quality BIM model. So that was the outcome in terms of that particular project. What we then did on the back of that was actually sat down and, right, what can we actually do? Now, as I said at the start, you'll get copies of these, so I wouldn't expect anybody to try and even read through what's on a very, very busy slide. And I'm not going to read through it either myself. The principle here is you've identified where you want to put in your effort, and then you start to think, right, what are the actual potential solutions? And you can see when you say plant rooms, there's quite a bit. I think from an OSM point of view, the building services sector is probably further ahead than a lot of other manufacturing techniques. The closest to building services, probably volumetric modular residential accommodation, which again is expanding with a push from the government in terms of the housing shortage, and numerous companies actually investing in that particular sector. So that's where we got to with the hospital project. So we analysed the building potential project as to what elements there were. We then set out to identify which ones would have the biggest benefit, the most opportunity, perhaps in reducing costs, reducing time, improving quality, eliminating legacy issues. And then we sat down and we actually looked at what are the actual potential solutions. And then the team started to actually look at these various things. So one of the biggest things was the horizontal service runs. So I've had a little think about it, and put the matrix is developed slightly from the early one. That, as I say, the hospital version was effectively early days, first thoughts. How do we actually go about this? And there are other techniques. I think you'll find that a number of people have actually been looking at this and trying to understand exactly how to go about it. So I've listed a few things down the left hand side. Be quite useful to get some feedback on this. But you could obviously bridges are obviously a fairly bridges are an obvious element that can be offsite manufactured. It may well be that you would actually look at a bridge on its own, and go into all the different elements of it. So whether it be the abutments and whether there's railings, etc., the bridge deck, the bridge beams. So it may well be that you use this technique and you concentrate on one particular element rather than trying to identify quite a wide range of elements which you might actually then incorporate. And then the principle behind this with the categories. So you've got the assessment criteria across the top. Obviously, you can see that suitability, statutory compliance, etc. And then the principle behind that is to actually ask the question: Is a structural system or prefabrication appropriate for the project type and functional requirements? And again, you approach yes, no. You would score that in a binary system. So just asking that question, asking these questions, you would identify, in theory, identify the areas where you need to do more investigation, more detailed investigation, and follow up. But it's a simple yes, no. As I say, that the objective here is not to zoom in, focus in on one particular thing. You do need to keep your options open to a certain extent, but you need to find out more information. Once you've actually identified where you think the opportunities are, it's a case then of going away and actually doing more research. And it may well be that you come back with that research and you do a further assessment to try and eliminate certain alternatives. So I've done fairly well time scale wise. We had allowed an hour and a half, and I was thinking 5 or 10 minutes to allow some discussion. And what I'd like to do, and the knowledge that I'm obviously speaking to highways people as opposed to architects and designers, is to actually ask you what you actually think should be covered in future workshops. So we've been through the content. I'm just going to check the chat box again. Brian has put the link, which is at the bottom of the screen, into the chat box. If you want to open a separate window or open the chat box, Jamboard, sorry, on a separate device, quite happy for you to actually then put some post-its in with suggestions as to what we could actually pick up on for future workshops. I don't know, can everybody see the chat box, or is it simply just going to me and to panelists?
No, people are starting to they're starting to join there.
Excellent, right.
Now.
Yeah, I was going to open the Brian can open the mics if so if that's basically the end of the presentation, folks, other than Q&A. So what I will do is I will close the presentation and just go to the Jamboard. If you're not familiar with the Jamboard, it's basically sticky note. Helps if I can spell things. And then just save, and it will come up as a when you enter, you'll be given I think an animal as an identifier. if I just stop that share for now. I don't know does anyone want to ask any questions? If you want to ask a question, I think we can open the mics if you actually use the raised hand. Could we open the videos, Bryony, so that?
Yeah, what I'll need to do is I'll need to promote people. If they do want to speak, if anyone wants to either pop it in the chat if you have anything you want to speak to Ken about, or if you want to raise your hand, and then what I can do is I can promote you to a panelist, which means that you can then share your mic and your camera. So if you have got any questions, just pop it in the chat or raise your hand, and then we can promote you so you can speak directly to Ken.
Slightly different compared with most webinars where we tend not to actually open things up, but I'm just keen to get sort of some, yeah. Have you experienced resistance to offsite due to increased cost? Yes, I think one of the issues that comes up is that cost is looked at rather than value. It's like how do you value a reduction in program? How do you value an increase in quality and reduced legacy issues? I think if you snapshot things and simply look at the direct cost of the manufactured component or the assembly, it may well be more expensive. But if you look at the bigger picture, it can actually balance itself out, and that's an ongoing issue that it's something that comes up quite frequently in residential volumetric.
Got a question in the chat from Cameron.
Yeah, picked that up from Cameron. Yeah, it's DFMA at the moment. I think a lot of the manufacturers are actually keen to offer offsite manufactured assemblies, but we need greater adoption of design for manufacturing assembly. It's a mindset, but then again, allied to that are they looking at different delivery models, frameworks, just how DFMA can be incentivized. I mean, a number of years ago, the Ministry of Defence ran prime contracts where the risk was shared. It's quite fascinating that the prime contractor sat down with the Defence Infrastructure Organisation on projects, capital works projects, and actually looked at who was best placed to manage the risk, and therefore having the prime contractors throwing large pots of money at all of the risks. They took on board, the client effectively took on board some of the risks. And then and the principle of prime contracting was to cascade the risk management down through the supply chain to try and reduce the actual risk. Because again, if you've got, say, a low-level supplier, including a risk element, by the time you perhaps multiply that up through 3 or 4 steps up to the prime contract, you're obviously putting quite a large element into that. So that was DFMA and risk sharing and collaboration, different delivery models. They all make a big difference. The supply chain school recognised that DFMA is the enabler in terms of construction industrialization, and the first offsite overlay to the plan of work was actually produced in 2015, which I think was based on the 2012 REBA plan of work. So the current one was actually published last September 2021, and it's based on the revised 2020 plan of work. And I think one of the things, again, apologies if I'm harping on about architectural things, but one of the things that was recognised in 2020 is that I think it's stage 5 was originally described as construction, whereas now stage 5 is manufacture and construction. So it's recognition that we're moving on. We're having to look at different methods of construction, different ways of actually building things, whether it be buildings, infrastructure, virtually anything. Got a couple in the chat box. Who have we got? Oh, come on, speak to me. Yeah, so that's Cameron. That's a response to Cameron's question. Anybody, any other questions? And I know that normally as a webinar you wouldn't actually do that. Is there an education program? Unfortunately not. The Offsite school is trying to do the best it can. Build Offsite is working on that as well. There are a number of initiatives. I mean, what frustrates me as an architect is that there's no specific architectural training in terms of DFMA and offsite manufacture. I think the government is obviously pushing the OSM agenda. From what I can understand, that there is some internal education going on, and actually helping various national and local government organisations to understand exactly what OSM and modern methods construction DFMA are all about. I think that was one of the purposes of the definition framework, is obviously setting a common language. The redevelopment of the hospitals around the country are predisposed to consider offsite manufacture. And I think I read last year that one of the schemes in particular, the designers were actually asked to go back and think again because they actually hadn't taken it fully into account. Going back to the cost issue, one of the anecdotes which I have from work at Heathrow was an instance where a main contractor offered a prefabricated air bridge solution, but the cost consultant said it was too expensive in comparison with traditional construction. But what the cost consultant hadn't taken into account is the fact that being, I think, ready for use something of the order of 2 months earlier would mean that Heathrow would actually begin to get income and revenue from the air bridges 2 months earlier than traditional, which far outweighed the additional cost of the actual prefabrication. So it harps back again to the issue, the principle of actually looking at value as opposed to just pure cost. It's coming up for 5 to 11. Would basically, I think we've come to a natural close at this point. Thanks very much for your questions. Hopefully the session today has been quite useful. I've tried to base it around methodology and process as opposed to looking at specifics for the highway sector. It would be really great if you could complete the feedback forms. Bryony has put a link into the chat box. It'll take you 3 or 4 minutes to do that. All feedback is welcome.